morning students. In the last video we have discussed about the procedure of deleting of elements in the B tree. So now we have taken small example for better understanding. So the order of this B tree is 5. Okay, if the order of the B tree is 5, the root node can have one minimum of 1 key to maximum of 4 keys, whereas leaf node or internal nodes can have 2 to 4 keys. How I got 2 minimum keys is minimum children is p by 2, where p is 5. So 5 by 2 seed is nothing but 3 children it can have. Number of keys is p by 2 minus 1. So I will get 2 keys of the minimum, and maximum number of keys is p minus 1, where p is 5. So maximum will get 4 keys. Okay. So we have set of elements in the B tree. Now I want to delete these elements so that I can explain each case. Okay. So first I want to delete the element 64. If I want to delete the element 64, I need to find whether the element 64 is existing in the B tree or not. How I will search it? First I will check the root node. The root node is consists of 50 and 80. What I want to search? I want to search for 64. So 64 is greater than 50 and less than 80. So it will be there in between. So I will come here and I got 60. 60 and 70. The 64 is greater than 60 and less than 70. So it will be here. Okay. So finally I found the 64. So 64 is there in the given B tree. If it is there only, we can delete. If the element whatever you want to delete, if it is not there, we cannot delete it. Is it clear? So first we have to check how many keys are there in this node. We have 3 nodes are there, or 3 elements are there in this node. One is 64, 65 and 68. How many minimum it should have? Because it is a leaf node. If you see that this is a leaf node, see all the leaf nodes are at the same level. Maybe my drawing is not looking good, but because of the space constraint I have drawn like this. So all are at the leaf same depth from the root node. So minimum is 2. It is already having 3. If I delete 64, it will still have 2, which is minimum. So there is no problem. I can delete 64 without any problem. So now this node have 2 keys. Okay. So I have deleted 64 successfully. So this is the one case. The first case what we have discussed, if the leaf node contains more than the minimum number of keys, then you delete without any problem. So that is the step 1 we have done. We have deleted the element 64 without any problem. Okay. Next I want to delete 23. Where the 23 will be there? 23 is less than 50. So you come here. It is greater than 20. So you search here. Now 23 is there. Okay. So if I want to delete 23, if I delete it, what will happen? It will have one node which is 27 only. Sorry, one key element only will be there which is 27. So what is this case? So we cannot delete directly 23 like this. So what is the second step we have discussed? If the node have less than the minimum, or it has less than the minimum number of keys, we have to depend on the siblings. So for this node, what are the siblings are there? Only we have the left sibling, we don't have any right sibling. So we will try to borrow the element from the right sibling. Sorry, left sibling. We will try to borrow the element from the left sibling. So how I can borrow? Whether I have to check before borrowing it, can it able to give it to me or not? We have to check it. Means can I borrow it or not? If it gives one element from me, it will have already it is having 3. If it gives to me, it is 2. 2 keys in a node is allowed because minimum is 2, so it is allowed. So this left sibling is in a position to give me one element. So which element I have to take? See, remember one thing, whenever you are deleting the elements in the B tree, or always the B tree will have the property of BS tree, binary search tree. Okay, so you cannot take the 14 and keep here. Is it clear? So which element we have to borrow is that we have to take the in-order predecessor. In-order predecessor means the largest element from the left sibling. What is the largest element from the left sibling? Is 16. Okay, so 16 will come here. So 16 will be deleted and 20 will come here because 20 is at the root level. So 20 will come and 23 is there. You want to delete 23, you can delete 23 without any problem. So let me repeat again. Previously you have 23 here, 16 is there and 20 is there at the root. So you want to delete 23. If you delete 23, it will go for the underflow condition. So you will check whether any left sibling is there and right sibling is there. For this node, only left sibling is there. There is no right sibling. So once you found that there is a left sibling, you have to check whether you can borrow one element or not. Yeah, you can borrow one element from it. Which element you have to borrow? You have to borrow the in order predecessor. In order predecessor means right largest element from this one. So what is the largest element? 16 is the largest element. So 16 will come here and 20 will come here and you will delete 23. So now if you see, it is still following the B tree property and also the BS tree, binary search tree property, because the elements less than 10 are there in the left hand side of the 10. The elements which are there between 10 and 16, 16 will not be there here. So 10 and 16 will be there at 14 and 15 between 10 and 16. And the elements which are greater than 16 are 20 and 27 are there in the right subtree. So it is following the B tree property. So we have deleted the element 23 successfully. Now I want to delete the element 72. Where the element 72 is there? The element 72 is here. Okay, the element 72 is there. Can I delete 72? No, I cannot delete 72 directly, because if I delete 72, it will go for the underflow condition. Okay, if it is going for that one, so what I have to do? I have to check whether it has a left sibling or right sibling. For this node, you have the left sibling and right sibling. First we will check, can I borrow the element from the left sibling? No, I cannot borrow, because already it is having the minimum number of keys. Next I will check, can I borrow the element from my right sibling? Yeah, I can borrow an element from the right sibling. So which element I will borrow? Is it clear? Which element I will borrow? Because I am trying to borrow from the right sibling, so I will do the in order successor. In order successor means the smallest element in the node. What is the smallest element in the node? 77. Okay, so 72 will be deleted. 77 will come here and 75 will come here. Is it clear? Are you able to understand it or not? Because you are borrowing from the right sibling, so you will borrow the minimum key from the right sibling and you will keep it at the parent node, and what are the element is there in the parent node, it will come here. So that is the way you will borrow from the right sibling. So we have till now we have discussed three cases with three examples. First case is without any problem. The element is there in the leaf node, we have deleted without any problem, that is 64. And 23 we have borrowed from the left sibling, and 72 we have borrowed from the right sibling. Okay. In the next one we have to delete 65. Where is the 65 is there? 65 is here. Now can I delete it? No, I cannot delete, because it is having the minimum number of keys. If it is minimum number of keys, if I delete 65, it will go for the underflow condition. So what I have to do? I have to check whether left sibling is there or not and right sibling is there or not. So first I will check, can I borrow the element from the left sibling? No, I cannot borrow, because it is already having the minimum. Even still the same scenario will occur for the right sibling also, because even it is also having the only 2 keys. So I cannot borrow from the left sibling or I cannot borrow from the right sibling. So that is what another step. So you cannot borrow from any of its sibling. Then what we have to do? We have to merge this node with the left sibling by considering the parent node. That is the one scenario. Or you can combine these two or merge these two with taking the 17 as the parent node. So what we will do is that we will discuss both the scenarios. So if I merge this one, what will happen? Let me write only this one. I have 70. If I would do this one, 70 is there and 77 is there. Okay. Then 51, 52, 60, 65 you want to delete. You delete it now and then you have 68 here. Okay. You are merging these two and taking the 60 parent one, because for these two nodes parent is 60. Okay, so you are combining the parent also, and whatever the element you want to delete, you are deleting. So that's why you have 51, 52, 60 and 68, which will comes to the left hand side, and the right side you will have 73 and 75, and 78, 79 will be there here. Is it clear? This is one scenario. Scenario is either you can merge these two with the parent node. So we will write that scenario. That scenario will be, you will have 60 and you will have 77, and then to the left of the 60 you will have 51 and 52. Okay, to the right of 60 you will have, because you want to delete 65. Okay, so you are deleting 65, you will left with 68, and you will combine with 70 with the 73 and 75. Okay, and to the right of 77, as usually you will have 78 and 79. So you can take any of these scenarios, means either you can combine this node with the left sibling or with the right sibling. So you can take any one of this one. So I will take the combining with the left sibling, because I am a left-hander. Okay, always I will have the partiality towards the left hand side. Okay, yeah, those that are jokes apart. So we will replace this entire one with this one. Okay, please bear with the sound. Okay, sorry for it. I am helpless in this lockdown situation. I don't have any other alternatives. Okay, actually I am doing this one as I love teaching, because I am very much free. There are no classes in the university, so for my students I am doing it. Anyway, I am uploading in the public domain so that everyone can watch it. Okay, leave the stories apart. So we will construct this one. 73, 75 you have, and then you have 78 and 79. So I will erase this one. Everything we have written. Yeah. Sorry. Okay. So now come to this. We have deleted up to 65. Now I want to delete 20. Where is the 20? Is there 20? And one more thing. After you are merging this one, you have to check whether this parent node have minimum number of keys or not. There or not. Usually a lot of people will forget that one. But after merging, the parent node should have minimum. In this case, it has two elements, 70 and 77, which are two elements. The minimum number of keys are 2, so it is okay. So now I want to delete 20. Where is the element 20 is there? Element 20 is here. So if element 20 is there, left hand side there is a left sibling, there is no right sibling. Can I borrow an element from the left sibling? No, I cannot borrow it, because already it has only two elements. So what is the thing I can do? I can merge with the left sibling only, even because there is no right sibling, so I have to merge with the left sibling. If I merge with the left sibling, what will happen? You will have 10. Okay, 10 will come here, and 4, 5, 6 will come to the left of the 10, and 14, 15, 16, 20 you have to delete anyway, so 20 you will delete, and you will have 27. Whether 4 nodes or 4 elements in a node is allowed? Yeah, maximum up to 4 keys are allowed, so it is not a problem. But so let me replace this one with the entire diagram. So 10 will be there, 4, 5, 6. On right of it you will have 14, 15, 16 and 27. Now you please check it properly. Once I merged the two nodes, I found that the parent node have only one element, okay, which is an underflow condition. Okay, so if it is an underflow condition, what should I do? I have to check its left sibling or right siblings. Means I have to check its sibling. For this node, there is no left sibling, there is a right sibling. So what I will do, I will try to borrow the element from the right sibling. Whether the right sibling is in a position to give it? No, because it is only having two elements in it. So I cannot borrow from the right sibling. So what I have to do? I cannot borrow from the left sibling. I cannot borrow from the right sibling. So what I have to do? I have to merge these two again. Okay. If I merge these two with the parent node, how it will look is, let me write here. How it will look like is, you will have 10, 50, 70, 77 will be there. Okay. At the root node you will have 80 because you are merging with the 50 will be removed from it. Now see this one. First we'll see whether root node can have only one element. Yeah, root node have root node is permitted to have minimum one key, so it is not a problem. Okay. So we will draw the remaining thing. Left of 10 you will have 4, 5, 6. Okay. To the right of 10 you will have 14, 15, 16, 27. Okay. To the right of 50 you will have 51, 52, 60, 68 will be there. See, it is left of the 70, but now it will come to the right of the 50 because these elements are greater than the 50 and less than 70. So it is okay. So to the right of 70 you will have 73 and 75. To the right of 77 you will have 78 and 79. Okay. So this entire one I will erase and I will write this part. Okay. So please bear with me for 2 minutes. So at the root node you will have 80. Okay. To the left of 80 you will have 10, 50, 70, 77. Okay. To the left of 10 you will have 4, 5, 6. Okay. You will have 14, 15, 16, 27. Okay. To the right of 51, 52, 60, 68 is there. To the right of 70 you have 73, 75, 78, 79. Okay. This one I am erasing. Now after doing this one we have to check whether it is satisfying the B-tree properties or not. Okay. Leaf node or internal node can have maximum of 4 keys, so it is permitted, and all the leaf nodes are at the same depth only because this is the root node and these two are the intermediate nodes and the rest of all are the leaf nodes, so it is satisfying the B-tree property. So we have deleted 20 successfully. Now I want to delete 70. Okay, this is the another scenario. Still now we are deleting all the elements at the leaf nodes. Now I want to delete the element 70. Where is the 70 is there? 70 is there at the internal node. If I want to delete 70, see, I will write it here properly so that you will understand. You have a 70 here and to the left of 70 you have 51, you have 52, 60, 68 is there. To the right of 70 you have 73 and 75. Okay, I will not write the entire remaining part. For better understanding I will draw simply like this. So as it is an internal node, if you want to remove the internal node, you can replace the node with, as it is an internal element, please excuse me, as it is a element in the internal node, you can replace it with the in order predecessor or in order successor. Okay. Now if I replace it with the in-order successor, what will happen? What is an in-order successor? To the right hand side, find the smallest element and replace it. In-order predecessor is to the left subtree. What is the maximum element? The maximum element is 68. Replace it with it. Can I replace with the 73? No, because if I replace with 73, it will have less than the minimum number of keys. So that's why I will not go for the in-order successor. I will replace it with 68. So if I replace it 68, you will have 68 here, and to the left of it you will have 51, 52, 60. To the right of it you will have 73 and 75. So I will write it here. So you have 68, and to the left of it you have 51, 52, then you have 60, to the right of it you have 73 and 75. Okay. So I hope you have understood how I have deleted these 6 elements from the B tree. In the next video we will discuss about how to delete the remaining elements for discussing about all the remaining scenarios. Okay, thank you so much.